Hello and welcome to my channel. In this video I want to show you how to install the Reticulum network stack program, which is called RNSD in fact, and I'll be using the command line. Sorry about that, but it's a command line kind of operation here. And what I want to do is to show you quickly how to configure it simply and get it working with a radio node or an RNode that will use the LoRa protocol on 868 MHz in Europe for wireless communication of data. And as you probably already know, since otherwise you probably wouldn't have looked at this video, the Reticulum network stack is based on cryptography. It replaces the TCP stack, it doesn't need it. And it's a nice way of communicating in a mesh network that's independent, doesn't need a DNS server, and really is in beta phase apparently, but I find it very reliable. It works for me, so I want to share it with you. There's some information about the encryption. I'll put links to these pages in the description below as usual. There are various programs that you can use to communicate using Reticulum. The easiest one in terms of user interface is Meshchat from Liam Cottle, which works very nicely. I've made videos about that. The kind of server that's used for serving up pages using Reticulum is the Nomadnet network software, which is called Nomadnet, and which I've also made some videos about. And you can actually use this Reticulum system to communicate over anything that has a bit rate higher than 5 bits per second. Here it says that. It could be any kind of radio interface, piece of wire, wet piece of string, you name it. So I want to install it and just follow the instructions. Pip install RNS. So let's give it a try, see what happens. Now this software is written in Python, and I have Python, I think. I must have as a default install. It's a very clean installed Ubuntu. So if I type which Python 3, yeah, it's got Python 3 installed. That's nice, but I know it won't have pip installed, the package manager for Python. So I need to install pip. So we just do sudo apt install and then give it its proper name, which is Python 3 tap pip, which is like that. Trying to type properly. I don't like the keyboard on this laptop, but that's, yeah, password. So it's installing, yes, 221 megabytes will be used. So we're installing the package manager for Python so that we can install the Reticulum network stack, otherwise known as RNS. And then I'll go on to edit the config file to see what is possible there. So we just need to do pip install RNS. Oh, it's done it. So that didn't take too long, did it? So pip is installed it, RNS, and we can check that. It's called RNSD, the actual daemon. Pip. So how can we do this? RNSD tap version to find out if it's installed. Ah, look at that. Something needs to be fixed here. I needed to reboot the machine so that the pointer to the Python 3 is loaded. And so now, hopefully, it will work. If I type this, there we are. RNSD is installed and it's now running. And it's not running. It's got version 0.9.1, and probably we want to run it. And the way to start it is to type RNSD, which will start the daemon. And there was no config file because it's the first time it's run, so it's created one. And it's now running. And actually on this command line interface, as things happen, then information notices will pop up like a live log file, so you see what's going on. What I'm going to do is open a new tab in my here so that I can carry on doing things. Let's make the text bigger so you can see it while this is running. If I exit this, then of course the RNSD will stop. So it's running, and I can check what's going on. We've seen the version number. There's a nice command which is rn status to see what's happening. And there it is. The shared instance is my terminal that I'm using here. This is the mouse and keyboard and screen that's communicating with RNSD. And then the auto interface is the internet connection via TCP/IP, which is actually going through an Ethernet cable, but it also will work through Wi-Fi, whatever internet connection the machine has. So this is called the default interface, and it's up, so it means it's working, and that's it. There are no other interfaces added yet. And what I want to do is to edit the config file to add another interface. Let's have a look. You can also add these interfaces, which are very useful, the public test net. You can add in Amsterdam and between the borders, and then straight away you'll be able to get data in and out of the applications, like Nomadnet, for example. Until you do that, you won't be able to do anything or see anything very much. You need to add these interfaces if you want to see the public test net at least. What I'm going to do is I'm going to add a radio interface called an RNode, and somewhere here, RNode, if we click on this, then it'll show us this page. These are RNodes, or radio nodes, just like the ones you could use for Meshtastic, which I was playing with last year. This year I'm playing with Reticulum. So this is the particular radio node that I have plugged into the machine at the moment. It's a Heltec V3, but there are a lot of different nodes that are compatible, and there are more and more being kindly added by the author of this software. So hopefully you will have one that's actually in this list, or about to be in the list. Let me just check to see if it's plugged in, because I plugged it in via USB. So let's just do a quick LS USB. And yeah, this Silicon Labs UART, this is the chip inside the RNode, inside the Heltec V3. So it's present. I could also do ls/dev/tty. Let's put a star and pretend I don't know what it's going to be called. And there it is at the bottom, TTY USB 0. So that is the RNode that's plugged in, and it's been given this interface name as a teletype serial device USB 0. It's a member of the dialect group, and my user, if we can check what groups that is not in the dialect group. So it may be that I need to add that, but I won't do it yet, because I'll see what happens if I haven't done it. Living dangerously, and I may need to do it. I'm not going to do it now because I'd need to reboot, and I don't want to reboot just yet. So the RNode's plugged in, it's visible, and what I could try to do is try to configure it using this RNSD and see if it works, or if it complains that it can't find it. So how do we do that? We use one of the commands that comes with this RNSD package, which is used for configuring. And I'm just looking at some notes so I get it right straight away. And actually we can just ask for some info about it to start with, see if it's visible. So then it's RNode conf, and then tap info, and then that name. I could copy paste it, but I'll type it instead, /dev/tty. This keyboard. TTY USB 0. So, could not open. Doesn't have permission. Let me try adding it to the groups called dial out, the user, and then we'll see if it works. So that would probably be a good idea. I'll try that. So let me do it using sudo usermod, and then tap add, tap group, dial out. So this is going to add the user name, which happens to be user, to the dial out group. And we need the password. And to make this work, I need to log out and log in again, or reboot. So let's do that. So I have rebooted the machine, and hopefully now that command will work and be able to see the RNode that's plugged in. So that's the command that I used, and let's see what happens now that we have the user in the dial-out group. Oh, there we go, look at that. It worked. So what does it say? Okay, so it's already configured as an RNode, but I'll show you how to configure it anyway from the command line. That's actually the latest version, 1.81 of the RNode firmware. So here it is. It's a Heltec V3, as we know, for that frequency range, and it's currently, yeah, it's all configured nicely. When the software runs that accesses this RNSD, it'll have to tell it what frequency it wants to use and spreading factors and bandwidth and so on. This is just general information about the node that it could operate in this frequency range, and the maximum power is 22 dBm. 20 dBm is 100 milliwatts, and 22 is probably 140 milliwatts or so. So that's working now. That's all I wanted to see. So what I'm going to do now is to pretend that this RNode hadn't yet been flashed with the firmware, that it was blank, or had an old firmware. There is an update function for that. What I want to do is do a fresh install. So what I'm going to do is this command, rnode conf tap tap auto install, and then the address of that device. See what happens. Looking like it's working, that's good. So what do I need to do? Make some choices here. Various different kind of node hardware, and I have to select the right one, and here we are. Heltec V3 is 8, so I'm going to type in 8, return. Hit enter to continue. What band? So it's 868 megahertz, that's number 2. So we got, that's the correct device. TTY USB 0, LoRa version 3. You don't want to get the wrong device because you can brick a node if you try and flash the wrong firmware. I did that a few days ago. Then I had to learn how to unbrick a ESP32 device using Arduino IDE and all kinds of things, which I'd not bothered to use before, so it was a good learning experience for me. But if you don't want that learning experience, then make sure you choose the right one. So we've got a Heltec version 3, which is that platform. It's actually an ESP32S3, and that makes a difference. Anyway, I'm sure the software knows what it's doing, so I'll just say yes, and let's see what happens. Well, it hasn't complained yet, and it looks like it's flashing it, so, oh, there we are. Chip is ESP32S3. So that is the microcontroller chip on that board, I know, and it's going ahead programming it nicely. I will make a video about how to unbrick a bricked RNode or a Meshtastic node. I've got another one to practice on, a T-beam that I managed to put the wrong version of software on and bricked it. And I didn't know how to unbrick it, but I think maybe now I've got a better idea. So I'll be trying that in another video. Anyway, this is almost finished at configuring. So it's waiting for the board to reboot itself. I can't see the display. Normally it's nice to see the display because then you can see what it's doing, but I haven't done that. So this is probably the steps when you use the web flasher from Liam Cottle, where you have to do steps 3 and 4 to configure the device. This is probably doing the same thing from the command line. I imagine that is what is going on. And I'm just reading this at the same time, making sure that there are no nasty errors. Hopefully it's configuring it, it's rebooting again to be correctly configured, that it can be used by RNSD. So here we are. Yes, please donate. I think this is an excellent software project and I think it's worth donating to. So there we are, it's done. What I could do is check the thing I checked before, info about it, just to make sure. Yeah, so looks like it's successfully configured. No errors. Ah, it's validated. Last time it said not validated. So that's nice. It looks like it's ready to use so that the RNSD program can actually use it to communicate over the LoRa radio interface, but not yet because we have to put in some parameters into the config file for RNSD so that it knows what to do with this particular node. And The first time that RNSD ran, is it running at the moment? Probably, because I did reboot. Let's just do RN status to make sure it's running. No, it's not. So let's run it. Okay, it started. Now I want another tab to type commands into, which I'll do like this. Now I can type RN status. And now you see it is running, but as you see, there's no interface yet for that Heltec v3 RNode. So what I need to do is to edit the config file. And this is stored in the home folder. You have to remember to switch on show hidden files, otherwise you won't be able to see it because these are hidden. And you need to go into .reticulum and then config. And here is the config file that's been created by the first run of RNSD. And it is very short. Usually they're about 260 lines or more. So it's the default one. You probably should edit it. Enable transport is false. So this means it won't be forwarding packets on behalf of other nodes that are in a network that it'll be in communication with. So it's not like a repeater. In other words, that's false at the moment. Of course, you can turn this on if you want to build a repeater on a small device, which is what the aim of this is, in the end, to use a Raspberry Pi or Pi Zero. This instance, when it's running, is shared, so that means that a number of different programs can communicate via the Reticulum stack, RNS, that's on here. So you could have Meshchat running and also Nomadnet, and they would both be able to communicate via the same interface, which I think is very nice. Panic on error, no. More removal. Log levels, fine. Let's see what interfaces are configured, and there's only one, this one called auto interface, and that's it. So it's going to need some more of those. There is a way of showing an example configuration. If I go back to the command line, if you type in RNSD tap and then example config, and you see a rather more full-featured config file, which is this. Let's go to the top. Much longer, as you can see. So it starts here. It starts off the same as what I just showed you, which is what the RNSD is currently using, but then you can start adding more things in, and I'm not going to go into all of these. Remote management and so on. Respond to probes is set to no. There is a command, it's like ping, and it's probe, and there are one or two others, which you can then use to do not a trace route, but a ping to a node. But if this is turned off, it won't respond to those. There's another kind of a ping that does work even when this is set to no, a more simple one with basic information. So these are the interfaces. That's the one we just saw, the auto interface, which is enabled, set to yes. And then here's a few more you could add. A UDP interface, various interfaces, a server interface if you want to run a server, and so on. TCP client interfaces are useful to connect to other networks via the internet, or you can use I2P, another form of internet, to connect to those. What I want to do is to, however, have a radio node, and there's not an example of that in here, but I've got one I prepared earlier. This is the configuration that I'm going to use for the RNode interface, and you can see the frequency is set here, bandwidth, transmit power, spreading factor, and coding rate. Those are the values recommended for use in the UK, so I've put those in. Remember all the extra zeros because these numbers are in hertz, so you have to have the right number of zeros to get megahertz and kilohertz. So I'm going to copy that and paste it into the config file for this actual RNSD instance. This is the config file, and what I'm going to do is just paste it in there like that and save it with Control S. When I start it, it will load up what it loaded up before. There we are. In addition, it's loading this RNode interface that wasn't there before. And if we look at this, and if I type RN status, there you can see, instead of just these two interfaces, there's a third one that's been added. and this is the radio node. It's got a rate of 1.76 kilobits per second. Not much data flowing because it's not really in use yet. There is a battery in it, it thinks. I thought I disconnected it, but anyway, it's measuring the voltage anyway and reporting it back. And the noise floor, which is a little bit high actually, of minus 95 dBm. Normally it's minus 100 and something. So it's picking up a lot of noise, probably from the laptop, because the antenna is sitting right next to it. Let me just do that again, see if it's changed. Yeah, it changed a little bit. So that's how to flash the firmware to an RNode and then configure it, and then to put the data into the config file that's needed to communicate with it, and for it to communicate then over the radio interface. So that's all I want to show you at the moment. This then is ready to be used, this RNSD. It's ready to be called by other programs that need it, or just to run on its own for routing traffic through the Reticulum network. Thank you for listening, and if you found it useful, I hope it saved you some time. Please click the like button, please make comments and ask questions, and subscribe if you'd like to be informed when the next video is uploaded.